moves towards you, it sounds higher pitched. As the ringing moves away, it sounds lower pitched. This is the Doppler effect. As the clock moves towards you, the waves of sound are pushed closer and closer together, and you perceive a higher pitch. As the clock moves away, the sound waves are pushed farther and farther apart, and you perceive a lower pitch. This is true for clocks, and it's true for cars. It's also true for light, and this is how Deborah Fisher and her team infer the motion of stars. See, their light varies in color, in frequency, ever so slightly. So she figures that's a result of the star having motion toward us and away from us. Notice that if you and I are moving together, there's no change in the pitch of the sound. It's only when there's relative motion, toward you or away from you, that you perceive the Doppler effect. Well, let's get back to the show, because time flies!
So on night one, I'll come up and I'll measure a star like this, take an observation. It will take about 10 minutes and take about an hour to analyze. And I'll get the position of all of these lines. And then I'll come back a week later or a month later, and I'll observe the star again. And if there's a planet there that's caused the position or the speed of the star to shift, then you'll see these lines in a slightly different place.
This is the motion that planet hunters look for. This is a star, and this is a nearby planet. As the planet orbits the star, its mass influences the star's motion. It wobbles. Stars without planets spin evenly. Stars with planets orbiting them wobble.
And so you see the velocity changing, and then you see a line that's been drawn in. This is a theoretical model that fits the data. And
boy, does it fit the data.
If each one of these dots represents one night of data, one observation of the star, and you can see pretty quickly we knew that something was going on, that the star's velocity was changing, so we knew there was a planet there. And the nice thing is that once we get this mathematical model, and imagine that these future lines are missing here, the line continues, and when we come to the observatory, the next points that we get had better fall right on this line, or our model is wrong. If you look here, the wobble is modulated by a second one.
Yeah.
This one has two planets around it. And
How cool is that?
So stars without any planets would just have a constant velocity. All these dots would lie in a straight line. But a star that has a planet has velocity that changes. The star comes toward us, goes away from us in this orbit. And so that's what we're measuring here.
You think there's life out there?
I think it's likely, extremely likely, that there's some sort of life out there. So it's impossible to describe what that life might be like. I guess the scientist in me wants to stay a little reserved and wait until we have more data to understand what that life might be like.
But what about the romantic, passionate person?
Well, the romantic, passionate person believes that there's life out there and other civilizations and other beings. With all of the diversity of life that we have here on this one planet, it's hard for me to imagine that there isn't life on other planets around other stars.
The moment of truth has arrived for NASA's Mars rover. After a 6-month journey, the rover is about to land on the red planet. This is no easy thing. That last little bit is a free fall, with the spacecraft dropping like a Mars rock. There are small retro rockets to slow the descent, then bouncing like a fumbled football. If all goes well, the Mars rover, with all its precision instruments, will bounce down and roll to a stop somewhere in the target landing zone. Of course, a crash landing is always a distinct possibility. The best way to know what's happened 35 million miles away is if the rover fires up its computer and begins sending radio and video signals back to Earth. If the rover doesn't work, millions of dollars of research go right out the Martian window.
Do you see it?
What do we see?
NASA successfully landed 2 rovers on opposite sides of Mars in January 2004. The second rover, Opportunity, landed on the Meridiana Plana and rolled into a small crater. Close examination of the light-colored rocks along the lip of the crater revealed that not all of the Martian surface consists of volcanic lava flows. These small, blueberry-sized pebbles found embedded in the rock appear to be composed of hematite, a common type of iron oxide that forms in the presence of liquid water. Along with that, chlorine, bromine, and sulfur were found in the Martian soil in the same proportions that we see in old ocean floors on Earth. We figure they got there when an ancient Martian sea evaporated. These and other discoveries lead scientists to believe that this area was once soaked in liquid water. Perhaps it was once suitable for life. But while finding water is encouraging, no actual living organisms have been found. So the scientific community is now clamoring for more space missions to continue probing the mysteries of Mars. Because until we actually make contact with or observe space aliens, the question of life in outer space remains, well, a question.
If we got a signal from another world, everybody would have to stop and think.
Oh, absolutely. No, I think that it'll have a tremendous impact on us, even if we don't understand the message, simply knowing they're there.
Everything we know about medicine, everything we know about agriculture, everything we know about disease and pest control and so on is all based on studying that one example of life. Imagine if we had 2. We might be a lot smarter.
Finding evidence for life on another world would just be shattering, I think, to a lot of people. We'd have to reevaluate our place in the universe. We'd have to, I think, unite globally and understand that we're one people.
We've covered a lot of ground, but it's just the tip of the iceberg. Check out eyesofnye.org for more cool science.